Here, what is the purpose of using k nearest neighbor in the classification rule? Because the k nearest neighbor is mainly based on similarity of the features present in the object. So we have to do the classification rule. Among the algorithms, it is the most simple supervised ML algorithm. It is mainly used to classify a data point based on how the neighbors among them are classified. Here you can see that the kernel always store all the available classes in it, and it classifies the new cases based on the similarity measures among them. What is meant by k here? We know what is that n and n, nearest neighbor. And what do you mean by this k? Let us see that. Normally, that k value that refers to the total number of nearest neighbors that should be included in the majority voting process. Okay, here based on the chloride level and sulfur dioxide level, it has to be classified, and we have to identify whether it is red color or white. So the 5 nearest neighbors helps to classify a data point. Here the value of k is equal to 5. Unknown point should be identified as red because 4 out of 5 neighbors are identified as red. So the output should be red. The main challenge in this algorithm is that to find the parameter k. K is normally based on the similarity of features present in the object. It is a parameter tuning for better accuracy measurement. See, this is a new variable to be identified. The nearest neighbors 1, 2, 3. So the k value is equal to 3. Here the maximum is chosen as this red color. Okay, so can we classify as red? We can see that now. Here the k value is identified as 7 because 1, 2, 3, 4, 5, 6, 7. Okay, so if the k value is 7, now the maximum out is this triangular structure which is in brown color. So can be taken as this brown. First time when k equal to 3, it is taken as this red square, but when k equal to 7, it is that brown triangular like structure. So what value we should choose for that k is the main challenging thing. We can see that now. To choose the value of k, we have to note two main important parameters. Number one is that square root of this n. N represents total number of the data points present in it, and the k value always should be a odd number to avoid confusions between two classes of data. So while choosing the k, it should be a odd number, and that we have to find out the value of the square root of n, which is the total number of data points. So to reduce the error, we have to choose the value of k as high as possible. The main thing to be noted for a KNN algorithm is that all the data should be in a labeled term. Next, the data which we providing during the training must be a noise free. For example, here you can see a person weight and height is defined, and in which class they are going to belong, whether they are underweight, overweight or normal. Here in the class column there are some error occurs that we call it as a noise, undesired data present in it. Then the third thing is that the size of the data set should be small because the Scikit-Learn algorithm is a very lazy learner. See how a Scikit-Learn algorithm works. Here we are having a data set which contains a weight and a height of a person's, and it has a classification whether that person is underweight or normal. We have to calculate the BMI for a person who is having 57 kg weight and a height of 170 centimeter. We have to calculate the Euclidean distance to find the nearest neighbors. We know the formula for finding the Euclidean distance. So this is one point that is represented as AB, and this is one point that is represented as xy. The distance is marked as small letter d. So this is calculated by x minus a the whole square plus y minus b the whole square. So this is x, this is a. X minus a the whole square plus y minus b the whole square. So this is how a distance between a 2 point is calculated in a plane. Now we have to plot out a graph. In x-axis we are having weight and y-axis we are having height. So all the data points are marked here. Okay. Now we are calculating d1, d2, d3 with the help of the Euclidean distance point. So to find out the unknown data point, we calculating the distance among the points. So here these are all the data points already available. We have to calculate this unknown data point which is in red color. Now we marking the distance d1, d2 and d3. Okay. Now from this point to this point, that is a distance d1. Okay. So we have to mark the coordinate point of this xy, and this is AB means by using the formula we calculating d1, then d2, then d3. d2 is the distance between this unknown point to this point, then d3 is this point to this point. We calculating all the Euclidean distance for all the values. We have calculated the Euclidean distance of all unknown data point from all the points that we already known. Let's calculate the nearest neighbor at k equal to 3, because the weight we mentioned here is similar to the weights here and the height is similar to the category here. So we have calculated by using the nearest neighbor at k equal to 3. Now the total number of data points is defined by n equal to 10 here in this case, and we find out the square root of 10, that is equal to 3.1. So we have to take the k value as 3. As per the KNN algorithm, we find out the person who is having 57 kg and 170 centimeter height should be a normal. Now we can see a case implementation. Here our objective is to predict whether the person is diagnosed with a diabetes or not. So we are having a data set of 768 people. Now we have to find out whether who are diagnosed with diabetes or not. So the first step is to import all the required Scikit-Learn libraries. So import training, testing, then splitting, then standard scalar function for scaling operation, then k nearest classifier, then confusion matrix, then for performance measure, f1 square and accuracy score. So we have to load that diabetes data set. So based on the categories we are having the values: glucose, blood pressure, skin thickness, insulin, BMI, diabetes, the age and the outcome. The values of the glucose, blood pressure, skin thickness, BMI, insulin, it need not to be a 0. So we have to replace all the zeros. If it is a 0 means it is taken as an undefined function. So we have to replace all the zeros. Split the data set separately for training and testing the data. So the main rule of the thumb that implies that any algorithm that you are calculating the distance, then the feature should be scaled. We have to define the model here, that P that defines the power parameter that find out the matrix. The metric here is that Euclidean distance and n neighbors. Then we have to fit the model for training and testing correctly. Let's predict the results here. For the test set results we obtain. So finally we have to evaluate the model with the help of the confusion matrix. Then we calculate the accuracy score as 0.8181, which is 81.81% accuracy. We can predict a model that can predict whether a person is having a diabetes or not. So the accuracy here we obtained is 81.81%, is a pretty fair fit in the model. Thanks for watching the video. Meet you in the next video. Till then, it's goodbye from Vijay.